because we even did that. It's like for me, I prefer calculation questions. I just give calculation like three in one exam, then I'll just do calculations and one writing, then I'll move on.
Um,
So this question here, this is a linear programming problem, right? So the question says a furniture dealer deals in only two items, deals in only two items, table and chairs. Now he has 5,000, sorry, 50,000 to invest and has a storage space of at most 60 pieces. Now a table costs 200 and 2,500 and a chair costs 500. He estimates that from the sales of one table, he can make a profit of 250 naira, and that from the then and that from the sale of one chair, a profit of 70 naira, 75 naira. Now, he wants to know how many tables and chairs he should buy from the available money so as to maximize his total profit. Now, assuming that he can sell all the items which he buys, you are required to formulate a mathematical linear programming problem and then solve the linear programming represented in represented above, showing clearly the feasible region and then calculate the maximum profit. So we need to start from here. So if we look at it now, the understanding of the question be the first thing. Like I always say, we now understand the question and how we understand the question is like let's decide the variables. Like we're going to just create the variables like x and y. So we can say, okay, let's start from getting our variables. Okay, ready? So we have x. So x, we can say x should be the number of what tables to buy, and then our y should be the number of chairs to buy. Because he's going to buy two items here. Going to buy chairs, going to buy table. Understand? So our x should be the number of tables. You understand? X should be the number of tables to buy, a bit, and then y, then the y can be number of chairs to buy. You get? So now we need to now identify the objective or function. Said that before. Now the objective function here is let's say is what we want to maximize. You understand? He said he should maximize the profit. So our objective function here is to maximize profit. So in some cases, right, you can you can minimize when you are talking about cost. You know, you can only cost minimize cost. You cannot say I want to increase my cost. So sometimes when you read the question, the way the question even sound, you can know whether this question is to minimize. You can already know that okay, the objective function for this is to minimize or is to maximize. Okay, so let's move on. So we can say okay. So in this case now, we want to minimize. Sorry, we want to maximize our profit. So let's form this. Okay. So let me read the question again. He has 550,000 to invest and the storage space. The table costs five 250 2,500 and a chair 500, and then he estimates that from the sale of one table he can make a profit. Okay, he can make a profit of 250. Understand? That means he's making uh one table will give him 250, right? So that is where this comes in. So we can say okay, we have so 250 naira. Remember, when you are doing it on paper and pen, remember to put the naira sign. We are just trying to define some variable. So let's say we have 250 naira per a table, and then going to what is x is for table. Okay, that is multiplied by x tables. I'm just trying to form something by x tables, and then which that is the profit from the chair, and then which from the chair he said that, and then from the chair sale of one chair is a profit of sale of one chair a profit of 75 naira. So it should be 250. Um, 250x. Then from here we have, so this is for table, right? So now this is what I have here is I have 250 naira per table. That is times x. The x here is the table, right? So that is why I just put 250 x. So I'm just trying to just form something. So if I do for chair, chair is y. So let me just do for chair. So chair we're going to make, then from chair now we're going to make 75 naira. Understand, 75 naira per chair, right? The chair will be multiplied by y chair. Right? So that will give us 75y. 75y. So for us to get our objective function, objective function here now will be should should be to maximize our x, right? To maximize our z, which is a function, then it's going to be equals to 250x, right? 250x plus 75y. That's our objective function. You get, so the y, the x represent our what? Our table. Y, the x represent our y. So we need to find those x's. We need to find the x, we need to find y so that we can substitute, and then we already got in our objective function. So now let's find our y. Or that. Are we following? Are we together?
We are trying.
So good. We'll be together. We'll be on the same page. So now the next thing we need to do is that we need to identify our constraints, right? We this in linear programming, this is what is called a constraint. Already, if if you attended our last tutorial about linear programming, I already explained that. But constraints are just like restrictions or limitations on our decision variables. Now, what are our decision variables? Our decision variable are the x and y. Do you understand? So we are looking at what could happen that we actually stop this our profit coming to our account. You understand? We are looking at the constraint. And the constraint here now, for the table now, they said we are looking at the constraint here is the cost. We already seen that, okay, if you sell one chair, we are going to make 250. Or if you sell one table, we are going to make 100 and 250,000. Sorry, not thousands, 250 naira. But then we are looking at the cost. Now let's look at the constraint here for the table now is the cost. That is a limitation or it can be a restriction. So a cost of 250 naira for a chair, sorry, for a table, and a chair that we are going to make 75 naira profit. We are buying that chair, we are making that chair. For us to make that chair, it's going to cost us 500. That means we are selling it for 575 naira to make 75 naira as profit. Do you get now? So let's look at our constraint. So, and then another constraint could also be our storage space, like our storage space, because they said he has invest, he has 50,000 naira to invest and has a storage space of at most 60 pieces. So that is also a constraint because may want to you may not have enough space to actually keep all these items. So that's another constraint. So let's just try to put this into mathematical something so that we can now see it in simple terms. So let's say, okay, we are looking at the cost of table. Constraint one, right? Let's look at constraint one. Constraint one here is the cost, right? And then in constraint one, let's say constraint one is cost and cost. So let's look at cost of table, right? Cost of table now is 2,000 uh 2,500 naira. Understand? Chair, sorry, per table. Then multiply by what? X. So let me be using this one as multiplication. Multiply by X so that you see it very well. So if you multiply 250,000 by X, what do you get? Because now you want to make you want you when you multiply that by X, what you want to get at the end of the day, just the way we did it from here. To get when we multiply it, we have 250X. So what we have here is going to be two. What we're going to have here now is now going to be 200 and 2,500 X. Do you get? So let's look at cost of chair. Cost of chair. Cost of chair now is what we have. It is 500 naira. 500 naira per chair, right? So if we multiply this by X, right? By X, we're now going to have 500 what? Y. 500 Y. Okay. So moving on. So the next thing. Yeah, so now what we now have here is now going to be is this, and the total what again? The we are looking at, say he has 500 and sorry 50,000 naira to invest. You understand? So that is the total available money that this guy has. You get now? His the chair cost him 250. Sorry, the table cost him 2,500. A chair cost him what? 500, right? But the total money that this guy has to invest in this business is 50,000. So that means he cannot spend more than this amount of money. So if you like, let him go and be pricing chair about 200 chairs. The money he has for investment is just 550,000. So that is where you now form this. Now the first equation here, right, is going to be 200 2,500 x, right? This is our constraint. 2,500 x plus plus 500 plus 500 y is now less than, okay, is now less than, so less than or equals to, yes, you understand, less than, you know that inequality sign, right? That's what I mean. Less than or equals to, that's the inequality sign. Less than or equals to 50,000. It cannot be above that. It have to be less than or equals to that. Right. Perfect. So less than or equals to 50,000. So let's look at another constraint. Constraint one now, two. This constraint two now is our storage space. storage space. To get storage space. So here now, they say that each table, right? Each table takes one space. So each here will also take one space. So, but the maximum space that it's going to have 60 what pieces. To get now 60 pieces. So that is the constraint. So that means he's going to have x plus y is now uh less than or equals to 60. Do you get? So you have found your inequalities. So for this one, this is your first constraint is the cost, and the second, this is your first constraint is the cost. And let me make it bold so that you see it very well. It's the cost. Okay? So the second constraint is the space less than or equals to 60. So now we now move on to solve. Okay? Okay. Do we understand? Small, small.
Yes, you can go on.
Okay. Thank you. So now we are going to kind of do some equations. So these are inequalities. We will now convert them into normal equations instance so that we can solve. So let's need to read the question. The furniture deals with this and has investments related to. So if you want to know how many tables and chairs he should buy from the available money, so as to maximize his profit, assuming that he can sell all the items which he buys, you are required to formulate the linear equation. Okay, so the linear formulate the linear programming problem, 2 marks. So far, what you have done now, you already gotten 2 marks already, and so 2 marks don't show for us. So the next thing, solve the linear programming presented above, showing clearly the feasible region. So that is 6 marks. We have not started looking for 6 marks. So we start looking for it. Hmm. Okay. So now if you look at this constraint, like the values are very big to get, are kind of big. So in linear equations, what you can do, we can either if we want, we can actually simplify these equations. Do you understand? To make the value small. Instead of making it big, we can make the value small. I don't know that you understand. So that we can now have smaller values to deal with. But let's just move on with the values that we have here. So now we're looking at the intercept. First of all, we now have to look at we want to solve it graphically because they said we should solve this one graphically. No, no, I think someone was asking when they said solve graphically, that doesn't mean that they have to plot a graph. That is not this graphically just a method of linear solving linear programming. It does not mean like you must plot a linear graph to be identifying that. You don't really need to draw any graph. Except you want to draw a graph, it's still fine. Mm. But we just need to simplify this value because it's too big compared to this. it may kind of give us some small issue because these values are very large, especially this 50,000 naira to 600 to 60 naira is really, really large for me. Do you get? It's really large. So how do you think we can do that? So we can actually simplify this by saying, okay, let's just say, okay, we will simplify this by we can just simplify this by dividing every item here by 500. The thing is, even if you take this thing, it will actually give us the same. We are actually going to get the same answer at the end of the day. Trust me, it gives us the same answer. So we can simplify this by dividing every item by 500. And then why do we divide it by 500? So we now talk, okay. If you divide 200, 2,500 by 500, what do you get?
5.
Five.
Get 5. Okay? Then that's going to be 5 plus 500 divided by 500 give us 1. That is going to be
Yeah.
right. And then less than or equals to the 500 divided by 50 give us what? 100. Sorry, 100.
Well, yeah.
Now, why we do this is because if you look at this value, it's really very, very large. It does not change the relationship or like what we are doing here actually, it does not really tamper with the constraint or whatever. It does not change the mathematical relationship. It's just the same thing. But if you don't do this now, if you look at this value and this one, it is too high. The difference is very high. So it will not be when it will not really fall in the graph. Just imagine, okay, you want to plot the graph like this, and you start from zero. And the zero start you are starting from zero. And this is how supposed to be like. So this is x and this is x. And this one is even starting from one. This one is starting from 200 and 2,500. That means if this is x, if x is zero here, another x is going to be from how can you get a 2,500 in on that graph? I don't know that you get the point of what I'm trying to explain. You get so that is why we just have to do that. We just divide everything and make it simple. Make the value just seem small so that it be easy for solving. It does not change anything. It will give us the same thing that we are looking for. So let's just move on with that. So this is our cost constraint. This is a new one. So now that means we have two equations now. Do you understand? We now have two equations. So for the storage constraint, we still have our x1 plus y1 and then less than or equals to 60. So this now looks better. right? So this is what we need. So now what we need to do now, right? For the budget constraint, which is the first one, we need to get our this thing, our intercept. We need to get our y-intercept, you understand? And we also need to get our x-intercept. Now, how do we get that? Now, when x is equals to 0, what is going to be our y? So we need to get our y-intercept. So when x is equals to 0, when our x is equals to 0, right? What is y? When x is equals to 0, y is now equals to y is equals to what? 100. Am I correct or not?
Yeah, correct.
I'm correct. Thank you. So that means this is the coordinate we have there. So we have this. So now for this one, when x is equals to 0, and then when x is equals to 0, okay, we need to get this for two items. So when x is equals to 0, y is equals to what? 100. So when y, right now, when y is equals to 0, when y is equals to 0, what is our x? Hmm? What is our x? Our x is now 500, 100 divided by 5. Abi? It will give us 5.
Yes.
Abi 20. Is it 5 or 20? Because 5, 100,
20.
right?
20.
20, Abi. Perfect. So our x is now 5. So what we have now is 20, 100, 20, and 0. Okay. So when x, under this our space constraint, when x is equals to 0, when x is now equals to 0 here, right? What is our y? Y is equals to y is equals to 60. When y is equals to 0, hmm? When y is equals to 0, what is going to be our x?
60.
60. Perfect. Spacing is available. Okay, so Sammy here, let me just write the coordinate so that we know where to use it. So we now say, okay, here when x is 0, when it's 0, this is 60. So for this one, we are going to make 60 here. I mean, our x is now equals to 60. So it means that we now have 60, uh, now 60 and 0 to get. So fine. So we now move on to identifying the physical region. Which region now are we going to use to do that? So, but before we do that, all this one, let's solve the simultaneous equation. Let's solve it. Let's solve these two equations now. Do you understand? So that we can see, we can now use this to now determine the physical region. So let's move on to solving these two equations simultaneously. Right? Is it simultaneously like this? 10 simultaneously. Okay? Correct. If not, then concerning. So what we're going to do now, we convert the inequalities now into normal equation, right? So what we have here, this is 5x, right? Uh, 5x plus y is now equals to 100. So this will be our equation what? Equation one. Get? So that one should be our equation one. Then this one now will be x is now equals to 60. Equals to 60. Then this should be our equation two. Yeah, we have two equations now. So we are solving these two equations simultaneously. So what we do now, right, to solve, we can then subtract equation two from equation one. Do you understand? So we can kind of subtract, I mean, equation what? Two from one. So how do we do that? So this is equation one, right? X 5x plus one, and then minus x plus y, then minus 100 uh, minus 60, right? Abi? So now look at what we have now, right? We just minus equation what? 1 from equation 2 from equation 1. So we just carry this guy, minus it here, and then we just, what I did, I just collect like 10. So that this x plus 1 y, this is this guy minus this, and then I'm taking every this constant values now into the other side, right? So 100 minus this. So if I do this, right, 5x minus x, I will have 4x. Then y minus y, I'll have 0y. That means there's no y again. The 100 minus 60, I have 40. So I want to have 4x, right? 4x is now equals to 40. Then I will now say, okay, divide both sides by what? 4. Then if I divide both sides by 4, my x is now going to be equals to what? 40 divided by 4, it will give me 10. So I have gotten 10
10.
for x. Do you understand? So now we'll now do substitution. We can pick any equation, whether equation 1 or 2. We can just pick any of it and substitute, and then we'll get the answer. So if I substitute in, I can just decide to pick equation 2. You get? I can pick equation 2. I can say, okay, substitute equation what? Substitute x in equation what? 2. X in equation 2. Then what do we have? Equation 2 is x plus y is equals to 60. Do you get? So that means I will now say, okay, x is already what? 10. Then 10 is plus y is equals to what? 60. Do you get? So 60. Now I want to now make y the subject of the formula, right? So I will now say y is now equals to 60
Equal to
minus 10.
50 minus 10.
Taking 10 to the other side, then I will now have y is now equals to what?
50.
50.
50.
50. Damn. So that means I solve
because there's still
this issue.
important, isn't it? That was a tough game in the second. In the second
Abi?
half, simply because
So in
I
this
think
Are
a lot
you
of
watching
people
that?
said the first half about chances
my what?
taken because chances they
I thought
change
you are
games.
watching match.
If
The
there's
game, is it
just
part
not
of
get
this
nervous in the second
equation?
half, they'll not drop off the pitch.
Sorry,
But
I
give
can't hear
Liverpool
you.
the time that they had, they would go for the
Mr.
lead.
Abraham,
I think that's what happened.
please, your mic.
The person I was asking question, thank you. Can you go ahead? You said?
No, I was talking to Abraham. He was saying damn. So I was
Okay.
asking whether it's part of the equation.
Okay, I didn't even hear that. Okay, so now we can see we have gotten what? X 10 and then y. Uh, y is now equals to 50. Okay. So moving on. So now the next thing now we need to determine our feasible region. You understand? So we get all these corner points, all the points that we have got, we bring them together. So, but then we now select the point that are. So if you look at it from here, when x is equals to zero, so I have this, I have this, I have this, I have this, right, for this constraint. So this is this particular constraint. What do we have? The constraint here is supposed to be 60. This is 60. And it's 60. What is it? 60 paces. Okay. 60. So this one was supposed to be uh, 50. But we reduce it to 100. Okay. So let's move on to getting our feasible region. So we have um, start from let's just say 0, 0, and then 20, 10, and so let's do this thing now. We want to calculate the maximum profit. We'll calculate the maximum profit. So we are going to use the objective function, right? We use our objective function to say objective function is here. So all this calculate all these things that we saw from here, we are looking at the possibilities, see how the values that can be used in this objective function. Where is it? This guy. This is our objective function. So let's go and do this here and solve. So now for this one, if you substitute x and y as zero, that means here automatically in this one you got zero. That means the zero naira, nothing you get. You get. So at this or this corner point, what we get here now is that we have 250, we have 250x. So x is 20. X is 20. So here we have 200, uh, we have 200 uh, times 20, and then plus 75y, and y is 0. That means what we have here is going to be uh 5,000. So here we have y and x. So we are looking at uh, so if we now here we now do equals to uh, 250 times 10 plus 75 times 50. We have, what's this? Plus 50, then we have this. And then here we have 250 is already zero. So what we have here is going to be uh, 75 times 70 times 60. Then we have 45. So now remember that we are looking at the maximum profit. So where are we going to get our visible region, which is this one? This one and give us the maximum profit. So this is the answer that they asked us to get. So now what happened now? Now this is what happened. What that means is like the person, this furniture dealer now have to, he's going to buy 10 tables and 50 chairs. If you buy 10 and 50 chairs, it's going to make 6,250 naira as profit. That is it. That's where you get the maximum profit. That means everything is going to be within that budget of what, 50,000. The way you understand.
Yes, but I have a question.
Okay.
I've not actually been following this linear programming. I want to know, why do you have 00? I thought what we had was 0 and 100.
Where was that? Okay. So
This
now,
visible result.
now the first one there, I just get at the point whereby a coordinate where, because if you draw now on the linear line, right, it both y
Yes,
and x are going to start from zero. You
yes,
understand?
sir.
It's just like I have
Yes, sir.
a point like this. I have a graph like this. Let me just say this is my x, and let me just draw the line. I have x and I have y, right? So when I set 0 and 0, and I have 20 and 0, that means I have 10 and I have 50. I have
Okay.
0 and I have 60. So if I want to plot a graph, if I want to plot a
Yes,
graph,
sir.
you're going to start from 0. Both corners are going to start from 0. Let me start from like this one, right? So this is a point 0. So at this point here, both y and x are actually starting from here. Do you understand? Both of them. So both of
Yes.
them have to start from there. When y is equals to 0, 10 is also equals to 0 at the same time. So that is why. So this one automatically likes it. So it's not really.
So we should ignore anytime I solve this equation, I should ignore the first one. I should start with 00.
Sorry, I didn't hear that.
If I come
This,
across this question or something similar and
mm,
supposed to plot a graph, I should start with 00.
so now, in a scenario whereby you are supposed to minimize, so when you want to minimize, you're looking at the least. Now, if you start with 0, 0, that means you are going to pick 0 because it's going to be the lowest. Now, let me
Okay.
explain this why it's like that. Do you understand?
Okay, sir.
Trying to look for my HO2 material list. Because in some, in some scenarios, like what you're going to do is you are going to get use. There's some question what they want you to do is to minimize. Now, if you look at it now, right? Why we choose 0, we choose 20, and then we have uh, this. We have this one. You know where we got this one? Abi? You know how we got this one? You
Yes,
know
yes,
why we selected
yes,
20? Now, for instance, this is
yes,
how, where we
yes.
got this one. Why did we take this one, not this one? And now here, why did we
Which
take this one? Why did we take this instead of this? Wait, which one did we take here? Okay, we took this one. We took this one. Why didn't we take this one? Do you know why?
why, sir?
Oh, you don't know. Okay. Okay. So now what means like we are selected. We selected the corner point, right? And the corner points here are they actually are they occur at the intersection of the two constraint lines. Now the constraint line here is your budget and your storage. Abi? So now
Yes, sir.
when we have this equation, 5x is equals to 100 and 5x plus y equals to 100 and then this. So now when x, now if you look at the lower side of the corner point, when x is equals to 0, y is equals to 0. So do you understand? That is the first. I'm saying why I picked the first one. That is why we picked the first one. When y is equals to 0, x is equals to 0. So those ones are just there for that one. So now when we come to this one, when we come to selecting this one, let's just say this one is the origin from where the graph is
Constant.
plotting. Do you understand? Yeah, the origin.
Okay,
Because you have to start from zero plotting. To start plotting
okay.
from zero. Do you get?
Yes,
So
sir.
now, if you look at this one, mm, if you look at this one here, why we do not pick this guy? This one here, we are looking at the what is this? When x is equals to x is what? What is x for us? X is
0.
no, I mean the constraint.
Okay.
When we talk about x,
X is the tables.
we're talking about tables, right? And then we look when we
Yes.
talk about y, we're talking about chairs. Do you understand?
Yes, yes, sir.
Okay.
Yes,
So
sir.
now we want to check them from the first one here. Now y, which is so from this one here. Okay. From here now, when we do this equation here, when x is equals to 0, y equals to 100, then we pick what? 100, right?
Mm.
100 is less
Mhm.
than 100 is less than. Actually, okay, yeah, we are not using this. I know why. From here now, this is actually from the equation where this is coming from. Do you understand?
Okay.
So when
Yes.
we pick this here now, we are looking at the x. So x here is less than or equals to. We are looking at the check. X is less than or equals to on this one now. X is less than or equals to 100. And the 100 here is when when we simplify this, what did you get? We get 100. Do you understand? So this is like
Yes.
everything we are doing, like from all these our variables here. We're supposed to now get what is less than this guy, less than or equals to this. Do you understand? Less than or equals to 100. So then the storage on this one, the storage for this same equation, the storage is now y. Abi?
Yes.
Now the storage is now y. So what is storage? Storage is the constraint for storage is anything less than what? 60.
So why do you now take 60?
Hmm?
Why do we now take 0 and 60?
I don't okay, why we take 0 and 60 from okay from here.
Yes. Yes, sir.
Okay, why we take 0 and 60, right? Now when x is equals to 0, What is our y? 16. Abi? So x
Yes.
is what?
Yes. Sir.
X, X, when we talk about X, we're talking about table. Then that means
Yes.
then we are talking about Y, we're talking about chair. And then
Sure.
here now we are
Yes. Sir.
looking at the storage. Do you understand? We are voting for this one where we selected there was for X. Here we are looking for Y, which is this one.
Okay.
So we choose this one.
Okay. All right, sir. Thank you.
So that's just calculate the maximum profit. Okay, that means we finished submitting. So this is our maximum profit and 606,250. Then we are done solving that particular question and we are putting the answer. That's all. So all these questions are they are kind of practical questions, right? So the first thing there is the understanding of the question. That's the understanding of the question and the principle you are using to solve. So we now start getting this value because all the values are there. So just get the values, move on with it. Hmm?